Yes, students, now we start with the next topic of the sets, that is the Venn diagram. How we can represent the operation of the sets by using a diagram. These diagrams are known as the Venn diagram. In a sets, the universal set is always denoted by the square, rectangular bracket, and let A, B, C are three sets, and sets are denoted by the circle. So first part of this, how we can represent A union B. Let me suppose that A and B are two sets. This part is something is common between these two. So what is the meaning of the union? We write down all the element of set A as well as B. The common element is written only single. So therefore A union B, we shade all the parts of A as well as B with a common part. So how we can write down the A union? We write down all the element of set A as well as set B. So Venn diagram of A union means all the element of A as well as B. Second part, A intersection B. A and B are two sets. What is the meaning of intersection? The common part between A and B. This part is the common part. Therefore, now we shade the common part. A intersection B. The intersection is this. Third part, A minus B. What is the meaning of A minus B? Only those elements which are left in A, means the intersection is subtracted from A. Only those elements, these elements are left. Now we shade this part. Similarly, B minus A and B are two sets. What is the meaning of B minus A? Only those elements which are left in B, means the intersection is subtracted from B. The common elements are subtracted from B, and only those elements which are left in B. So this part represents the B minus A. Fifth part, A delta B. A delta B is known as the symmetric difference. Symmetric difference means A minus B union B minus A. This is A minus B, this one is B minus A. What is the meaning of union? Means these combine these two parts. A minus B is this, B minus A is this, so union of these two parts. So it represents the symmetric difference. So this symmetric difference also represents exactly in once either in A or in B. Sixth part, how we can find out the complement of A dash. Complement of A means U minus A. Let me suppose that this rectangle represents the universal set and A set. So complement of a U minus A, only those elements are left from the universal set. So how many elements are left in universal? This from this rectangle, now we remove this circle. Remaining part is the complement of A. And next part, A union B whole dash. Universal set, A and B are two sets. So first, how we can find out A union B? A union B is this, all the element of A as well as B. Now we find out the complement of this. Complement is except this, except A union B. Now these elements are subtracted from the universal set. So the remaining part is this. Similarly, 8th part, A dash union B dash. Universal set, set A, set B. How we can find out A dash? U minus A. First you only shade the A dash. Red line shows the A dash except A. All these lines represent the A dash. Then how we can find out B dash? Make complement of B. Now only those elements which are left in the universal set except B. Except B. The blue lines represent the B dash. You find out the union of these two. If you find out the union in the complements, for the union of the complement, the single shade and the double shade, both parts represent the union. These outer part represent the double shade, and this is the single shade, black and red. In case of union, we write down all the common as well as uncommon elements. So therefore, A dash union B dash represent this part. Or except universal set minus A intersection B. This diagram represents the A dash union B dash. How we can find out this? From this. In case of if you find out the union, then you find out all the elements which are represent the single shade as well as the double shade. Ninth part, A dash intersection B dash. Again we get the same diagram, this. But in case of intersection, only intersection is common part. In case of intersection, only we write on the double shaded part. This outer part represents the double shaded. Therefore, it represents the A dash intersection B dash. 10th part, if A, B, C are three sets, then A union B intersection C. First, we draw three sets: set A, set B, and set C. What is the A union B? All the element of A as well as B with intersection C. So, what is the common part with C? A union B is this A and B whole, and intersection with C. Common part is this. This part represents the common in A union B. This part. Similarly, A intersection B union C. A, B, C are three sets. So, what about A intersection B? This part is it. Union with C. This part union with C means all the part this. This part represent A intersection B union C. These are the different type of the Venn diagrams, and one more property or the application of the sets. Application of sets. Let me suppose that A, B, and C are three sets. A, B, and C are three sets. So first we take A and B are two sets. We represent this part. So A, only A containing A, and whole A containing A plus C. B containing B plus C, only B containing B. Then N A union B, the order of A union B. A union B always represent the elements. A union B is this part, A, B, and this common part. So therefore A and A union B is always equals to number of element in set A plus number of element in set B minus A intersection B. The common elements are subtracted, and A, according to this set, this part A, this one is B, and this part is C, common part is C. So what about NA? A plus C, and B, B plus C, and A intersection B, C. What about NA union B? A union is whole part of this, that is A plus B plus C. This application for two sets, and if A, B, and C are three sets, then N A union B union C is always equals to N A plus N B plus N C minus N A intersection B minus N B intersection C minus N C intersection A plus N A intersection B intersection C. So this one set A, B, and C, and in this part there are 7 parts. This only A containing A, B, and C. D is this part, E, F, and G. The first part, the number of elements in set A. Number of elements in set A, that is A plus D plus G plus F. This whole part represent A. Number of elements in set B. This whole part is B, that is B plus D plus E plus G. Number of elements in set C. C plus E plus F plus G. Next part, what is the common between A and B? B plus G. Common between B and C? E plus G. Common between A and C? F plus G. And G is a part which is common for all the three sets, set A, set B, and set C. This part represents the common part. These are two properties. First, A union B equals to NA plus NB minus NA intersection B. And second, if there are three sets, NA union B union C equals to NA plus NB plus NC minus NA intersection B minus NB intersection C minus NC intersection A plus NA intersection B intersection C. In this part, so one more property of this by the same condition. If A and B are two disjoint sets means nothing common between A and B. It means the intersection is 0. Therefore, NA union B equals to NA plus N. In this part, if A, B, and C are three disjoint sets, nothing common between these three, then this one, this and this all are 0. Therefore, n A union B union C equals to n A plus n B plus n C. In case of if these sets are disjoint means nothing common between them. If the nothing common, it means intersection is 0. Okay.